Imagine waking up one morning and realizing that a single company controls the future of artificial intelligence. Not Google, not Apple, not Microsoft. A company that started in a rented office, built by an engineer who once washed dishes to survive. Today, every major AI system, ChatGPT, Tesla Autopilot, DeepMind, Meta's Llama, depends on one thing: NVIDIA GPUs. This is the untold story of how a small graphics chip company quietly rose to become the backbone of the entire AI revolution, shaping the world you live in right now. And the crazy part, almost no one saw it coming, not even NVIDIA themselves. NVIDIA's story begins in 1993, when a 30-year-old engineer named Jensen Huang sat in a Denny's restaurant with two friends, Chris Malachowski and Curtis Preem. Huang, who had immigrated from Taiwan and once worked as a teenage dishwasher, believed the world needed a new kind of chip, not for spreadsheets or office tasks, but for visual computing. At the time, the idea seemed almost absurd. Computers were slow, graphics were crude, and Silicon Valley investors had no interest in anything related to advanced graphics. But Huang was convinced that one day computers would understand the world visually, just like humans, and that this would require a fundamentally different type of processor. The company they founded, NVIDIA, struggled through its early years, brushing against bankruptcy multiple times. Their first major product, the NV1, was an ambitious but commercially disastrous chip that nearly sank the company. Rather than stepping back, Huang doubled down and pushed NVIDIA to create the Riva 128 on an incredibly tight timeline, knowing the company had no room for error. Against all odds, it succeeded and became a hit among gamers, pulling NVIDIA back from the brink and proving that the founder's vision had real potential. In 1999, NVIDIA introduced the GeForce 256, which they called the world's first GPU. This wasn't just a graphics chip, it was a new category of processor built for massive parallel computation. Gamers loved it, but the real impact would come years later as researchers realized GPUs could do far more than render 3D worlds. Throughout the early 2000s, scientists began experimenting with GPUs for physics simulations and complex mathematics. In those early 2000s years, NVIDIA was trying to convince a world that didn't want to listen. Most researchers were locked into CPU thinking: faster clock speeds, more cores, incremental gains. GPUs were dismissed as niche hardware for teenagers playing games. Even when NVIDIA engineers presented data showing GPUs could accelerate scientific workloads by orders of magnitude, the response was largely disbelief. But inside the company, a pattern was becoming clear. Whenever someone hacked together a way to run non-graphics algorithms on a GPU, fluid simulations, molecular dynamics, early neural nets, the performance jump was enormous. This wasn't an accident. It was the architecture. GPUs weren't built for sequential tasks like CPUs. They were built to attack huge problems in parallel, all at once. Jensen Huang realized they were sitting on a breakthrough, but he also understood something painful. It didn't matter if NVIDIA saw the future, what mattered was convincing the rest of the world. So he made a bold, almost reckless decision. NVIDIA would build a platform that let researchers use GPUs for anything, not just graphics. That platform became CUDA. It required years of investment, a new programming model, and a leap of faith from a company that wasn't yet profitable. At first, CUDA was ignored too, but a small group of scientists began experimenting, then sharing results, then publishing papers showing dramatic speedups. Slowly, almost silently, a shift began, and when deep learning researchers finally adopted GPUs, the combination unlocked an explosion of progress no one had predicted. What the world once dismissed as a gaming chip had become the engine of the AI revolution. Almost overnight, demand surged. Researchers who once cobbled together mismatched hardware were now building GPU farms in basements and university labs. What had started as a clever hack was becoming a movement. Papers that previously took weeks to train were finishing in days. Experiments that were once impossible became routine. And each breakthrough fed the next. Better models required more GPUs, and more GPUs enabled even better models. Inside NVIDIA, engineers realized something profound was happening. Gamers were no longer their only customers. Scientists and startups were treating GPUs as scientific instruments, NVIDIA leaned in. They rewrote software libraries, optimized drivers, and eventually built CUDA into a platform tailored for machine learning. Suddenly, deep learning wasn't just a research curiosity, it was becoming a scalable technology. The wider tech industry caught on fast. Cloud providers rushed to offer GPU instances. Venture capital began pouring into AI startups, each betting that neural networks could transform a new industry: medicine, robotics, finance, everything. And at the center of this accelerating storm was a company that had never intended to lead an AI revolution. By the time the world realized how much power deep learning would require, it was already clear. NVIDIA wasn't just selling chips. It was supplying the picks and shovels for a new technological gold rush. Before we dive deeper into how NVIDIA became the backbone of the global AI industry, a quick reminder from the Algorithm Archive. If you're enjoying this deep dive into the companies shaping our technological future, make sure to like this video, subscribe, and turn on the notification bell. It genuinely helps us bring you more high-quality explainers and cuts straight through the YouTube algorithm. Plus, you'll join a community of tech enthusiasts, entrepreneurs, and curious minds across the US and Europe who want to stay ahead in the world of AI and business. Alright, back to the story. NVIDIA's CUDA bet was so radical because it flipped the entire GPU business model. In 2006, GPUs were still seen mainly as graphics chips, and the idea of using them for general-purpose computing sounded fringe. Building CUDA wasn't just writing an API, it required redesigning hardware, hiring compiler engineers, rewriting toolchains, and convincing developers to think of GPUs as tiny supercomputers. All of that cost years of engineering time with almost no short-term revenue. Inside NVIDIA, CUDA was controversial. It diverted resources from products that were actually selling. Outside NVIDIA, it was worse. Wall Street wanted predictable GPU sales, not a long-shot software ecosystem. Competitors dismissed the idea entirely, assuming open standards like OpenCode would make CUDA irrelevant. But Jensen Huang understood an asymmetry. If parallel computing became important, the winner would be whoever owned the software, not the silicon. CUDA quietly built a multi-tier, more libraries, more optimizations, more researchers trained on its tools. By the early 2010s, deep learning researchers were hacking GPUs for neural networks, and they naturally gravitated to the only platform that made it easy to experiment: CUDA. By the late 2010s, NVIDIA had become the beating heart of the AI revolution. The company's early bet on general-purpose GPU computing years before deep learning took off positioned it perfectly for the moment neural networks exploded in capability. When researchers realized GPUs could train models dozens of times faster than CPUs, NVIDIA's CUDA ecosystem became the default platform for anyone serious about AI. OpenAI's early GPT models ran on vast clusters of V100s, and Google's breakthrough image recognition experiments also leaned on NVIDIA hardware before TPUs existed. Tesla built its first Autopilot systems entirely on NVIDIA's Drive platform. Meta, Amazon, Microsoft, Baidu, and virtually every major lab standardized their research pipelines around CUDA, CUDA, and NVIDIA's optimized libraries. Even universities with limited budgets preferred NVIDIA because its software stack made cutting-edge research accessible. What truly set NVIDIA apart wasn't just power, it was usability. CUDA locked in an entire generation of developers, creating a feedback loop. More developers meant more optimized software, which meant better performance, which meant more adoption. Huang understood this deeply. When he said NVIDIA was in the world-changing business, he framed GPUs not as chips but as the backbone of a new technological era. By 2018, NVIDIA wasn't merely enabling AI research, it was shaping the direction and speed of global innovation. Its hardware became the invisible infrastructure behind breakthroughs in drug discovery, robotics, climate modeling, and natural language processing itself. When the generative AI wave hit full force, NVIDIA became the choke point of the entire industry. The A100, and later the H100, weren't just faster chips, they were the only chips capable of training frontier-scale models within practical time and cost limits. Every leap in AI capability depended on access to them. As labs raced to build larger models, GPU clusters became the new oil fields, and NVIDIA owned nearly all of the extraction equipment. Cloud providers scrambled to secure long-term supply agreements, sometimes paying years in advance just to guarantee allocation. Startups with no product but a signed NVIDIA purchase agreement raised hundreds of millions from investors desperate not to miss the AI gold rush. Government agencies from the US to the EU to the Gulf states treated NVIDIA hardware as a strategic asset, competing for shipments the way countries once competed for semiconductor fabs. The scarcity created a kind of GPU mercantilism. Secondary markets emerged where H100s traded like commodities. Some firms hoarded chips, others rented them out at massive premiums. NVIDIA's quarterly earnings began to dwarf expectations, quarter after quarter, as revenue from data center GPUs eclipsed every other segment. For a brief moment, NVIDIA wasn't just participating in the tech industry, it was dictating its pace. Software giants, research labs, automakers, and national governments all found themselves dependent on the same supply chain bottleneck. In the span of a few years, GPUs went from specialized hardware to the steering wheel of global technological progress, and NVIDIA sat firmly at the center of it. Today, NVIDIA stands at the center of the AI universe, but the question is, can anyone stop them? AMD is trying with its MI300 chips. Intel is scrambling to reinvent itself. Google, Amazon, Meta, and Microsoft are building custom AI chips to reduce dependence on NVIDIA. Even Tesla is building its own supercomputers. But NVIDIA still leads with its unmatched combination of hardware, CUDA software, developer ecosystem, and decade-long AI dominance. As long as AI keeps growing, NVIDIA remains the backbone powering it all. The world may debate the future of AI, but one thing is certain: NVIDIA is the company making it possible. And that wraps up this deep dive into NVIDIA, one company that quietly built the hardware, software, and vision powering the entire AI revolution. If you enjoyed exploring the story behind the engines of modern technology, make sure to stay with us here at the Algorithm Archive. We break down the companies, ideas, and hidden forces shaping the future of artificial intelligence. If you haven't already, go ahead and subscribe, leave a like, and turn on the notification bell so you don't miss our next investigation into the tech shaping tomorrow's world. Thanks for watching. And as always, stay curious, stay informed, and I'll see you in the next one.